Okay, we've got an exponential graph here, and we've got to determine its equation. So the 2 points that I see that we can definitely say are on the graph are this point here, and maybe a point up here. I'm going to use these two, though. So I see that 2, 1 is on the graph, and 4, 4 looks like it's on the graph. Those are like the points that are easily worked with. So that means that f of 2 is 1, right? And f of 4 is 4. So I'm going to use that. I know it's exponential. I want to find that growth factor. So how do I get from 1 to 4? We don't know what f of 3 is. It skips that. So to get from f of 2 to f of 3, we multiply by something, x. Then we multiply by that same thing again, x, to get 4. So we start with 1. We're multiplying by x, and then by x again to get 4. Well, 1 times x is x squared, and we got to figure out x to solve the equation x squared equals 4. Take the square root of both sides, or it's just obvious, the x value is 2. It could be negative 2 too, but in this case, we know it's increasing, it's 2. So I know that the growth factor is 2. Now I've got to figure out what's the starting value, and that's where 0 is. Okay, so I need to work backwards from f of 2 to get f of 0. So when we're moving to the left, we're going to divide by 2. So 1 divided by 2 is a half, and a half divided by 2 is 1/4. So that's my initial value. So the full expression is 1/4 times 2 to the x. So to write a full equation, we want f of x is equal to 1/4 the starting value times 2 to the x. And then it says explain how you determine the equation. You would, unfortunately, have to go about explaining this process in words. First, I determined the growth factor by finding what I could multiply 1 by twice to get 4. Then I used that growth factor to work backwards to get the f of 0 value, which I knew was the starting value. Okay, 37. This is probably the hardest question on a Regents exam that I've seen. But here it is, the last question. It's worth 6 points. There's a lot of room for partial credit, but we want to get full credit, and we will. So here it is. We've actually done a problem very similar to this, if not this problem. But we got a small garden that was a square, so each of the sides we're going to call x. And you got a new garden. One of the sides is doubled. The other one's 3 less than it used to be. So we're going to call this side x minus 3. We're going to call this side 2 times x. So we need to write an equation that models this situation. So we have 1.25. Oh, I'm sorry. And it says that this new one is 125%. Or I'm sorry, 25% more area. So that means in order to get this area, you'd take the smaller rectangle and multiply it, or the smaller garden and multiply it by 1.25. So I wrote the equation. 1.25 times the small area is going to be equal to the larger area. So in formula form, that's the small area is x times x, or x squared. So 1.25 times x squared is equal to the length, the area of this one, which is length times width, 2x times the quantity x minus 3. So then it says explain how you determine this. I wrote out what I just said. X squared represents the area of the small garden. 2x represents the doubled side, right? X minus 3 represents the side decreased by 3. And then, I should say this. 2x times the quantity x minus 3 represents the area of the larger garden. And then I said if you increase the smaller area by 25%, you get the bigger area. And that explains the 1.25 times the smaller area. Okay. Then to determine the dimensions of the garden, I just solved this equation. I won't go through all the steps. I'll just go through them quickly. I subtracted 1.25x squared from both sides to get 0 equals 0.75x squared minus 6x. I divided everything by 0.75 to get the coefficient to be 1 for the x squared. That gave me 0 equals x squared minus 8x. And then I just solved using completing the square. Took half of this, squared it, you know the routine. And I got that x could either equal 8 or 0. Clearly it's not 0, so it's got to be 8, and that makes the area 16 by 5 because you plug the 8 in for here and here. And that's 80 square meters.